Hello everyone, my name is Ashish Sangave and I am going to discuss the mechatronic system of vending machines. Before starting, I would like to thank Dr. Wagner for giving me this wonderful opportunity and also the Department of Mechanical Engineering at Clemson University for the access to vending machines. I would also like to mention that all the images and animations used in this video are my own creation. These are some of the topics that I will be covering as a part of this video. So as you might know that vending machines are automated machines used to provide products such as snacks, beverages, stationery after a predefined amount of payment is performed. There are mainly two types of vending machines. Firstly, processing after payment types which are used for coffee making, and the other ones are ready to dispense types which we will be discussing throughout this video. The parts of a typical vending machine consist of a payment zone which has a card or cash payment option, a keyboard to make product selection, refund zone to collect the change after the transaction, vending channels where the products are placed, and the pickup zone to obtain the product. The process flow for vending machine starts with the idle state. It is important to note that the vending machines are powered even in the idle state. Second state is awaiting payment. When the payment process is performed, the deposited amount is compared with the product amount. If it is greater than or equal to the product amount, the next state is pursued. Otherwise, a message is displayed on the LED display to perform additional payment. In the next state, the selection of payment is required, which leads to dispensing the product followed by refunding of the change. If at any state of this process the timer runs off or the consumer cancels the process, the change is automatically refunded. The money acceptance mechanism of the vending machine includes bill or currency acceptance and coin acceptance mechanism apart from the typical digital card payment. For the paper currency, LEDs are used to shine light on the bill and detect using optical sensors, which is then compared with the images in the database to determine the demonstration. The coin acceptance mechanism is a bit more complex, involving weight and electromagnetic sensors to segregate between coins. The oscilloscope in this mechanism sends the signal for acceptance or rejection based on its properties and deviation. While discussing the product actuation mechanism, on the left hand side, as you can see, the actual mechanism in a vending machine, and on the right hand side is the CAD model designed for a better understanding of the situation. The system consists of DC motors to actuate rotational motion of the helical structure or the spiral structure, which holds the products and drops it after a specified number of rotation. The input rotations are programmed in an Arduino or microcontroller. Now here is the system architecture for the entire vending machine mechatronic system. There is a power source connected to the Arduino or microcontroller, a timer to cancel the operation at any point of delay, a currency validation system, and LED display to connect to both currency validator and microcontroller. On the input side, you can see 9 AND gates because in this we are considering a 3 row by 3 column vending machine. And for each of these 9 inputs, there is one output motor to actuate the specified combination compartment of helix. Now discussing the analytical solution for this system, I decided to perform velocity analysis. For the helix, as it is crucial to have a fixed velocity to avoid any possible damage to the product. So first I have noted the state space parameters for a helix, which are x is a cos theta, y is a sin theta, and z is b theta. Now representing theta as a function of t, I wrote down the equation of motion for helix, which is r of t is equal to a cos theta of t I cap plus a of sin theta of t j cap plus b theta of t k cap, where I, j and k cap are unit vectors along the directions x, y and z respectively. Then the desired velocity vector can be obtained by differentiating the equation with respect to t, and finally taking modulus of the vector, we get the magnitude of the velocity. Now I'll explain you a demonstration of the vending machine. Here is a typical vending machine in front of me. I'll be using a credit card for that purpose. I'll swipe the card over here, and when the screen shows that I am ready to choose the product, I'll choose a product. Now it says card approved. I'll choose a product, and now the product will be dispensed automatically. These are some of the references that I have used to gain the knowledge for this project.